When your coding agent makes the same mistake twice, the agent is not the only problem. The problem is usually the system around it. Without clean failure cases, checks, and a review loop, an error becomes just another chat message. With orchestration, it becomes an improvement engine. The hype around Codex and similar agents often makes it sound as if these systems learn on their own. A more technically accurate view is this: they improve a specific run when you give them errors, context, and evaluation feedback. You need to understand that difference if you want to use AI agents as a work process, not just a demo. OpenAI describes two core approaches to agent orchestration. Either you let a model decide which steps and tools to use, or you control the flow in code. Both can be combined. The crucial point is not magic, but structure. An agent receives instructions, tools, handoffs to specialist agents, and feedback. It can then plan, execute, verify, and improve. The typical failure pattern looks like this. An agent writes code. The build fails, you paste the error back. The agent patches something, and eventually it might work. That is improvised, it feels productive, but it is hard to repeat. The next similar error starts the same game all over again. The better solution is a closed loop. First, save every error as a reproducible case. Not as a long chat history, but as clear input, expected result, actual result, and error message. Second, turn it into a check that can be a test, a lint check, a build step, or a small evaluator. Third, give the agent not only the task, but also the evaluation feedback. It should not guess. It should fail or pass against the criterion. This is where orchestration comes in. A manager agent can retain control and use specialist agents for limited tasks. For example, a planning agent for analysis, a coding agent for the change, a review agent for risks, and an evaluator to decide whether the output is sufficient. Alternatively, a triage agent can hand off to a specialist when that specialist should directly take over the next part. What matters is that not every agent has to do everything. That is why Codex seems interesting as an improvement engine. It is not because one model suddenly learns permanently from every error. It is because an agent workflow turns errors into data. Error messages, logs, tests, and reviews become fuel for the next run. The visible outcome is less gut feeling and more evidence. The agent did not merely change an answer. It passed a check. For teams, the practical difference is significant. Without this loop, you get fast suggestions but unclear quality. With this loop, you get a workflow that exposes errors, separates responsibilities, and keeps decisions verifiable. It does not automatically eliminate every problem, but it reduces the chaos around agent work. The checklist is simple. Save failure cases, write checks, separate planning, execution, and review. Use logs for diagnosis. Let an evaluator decide whether the result is sufficient. Improve prompts only once you know where the flow actually broke. The key takeaway: in day-to-day work, an AI agent does not learn through hope, but through feedback loops. If you use Codex only as a chat window, you get better autocomplete moments. If you put Codex into a tested agent process, you build an improvement engine. Share this with your team to save time.